I'm Tim Ventura, and we're joined today by Dr. Eric Felt, a space technology strategist with over 20 years of defense aerospace experience, leading labs, test, program offices, and Pentagon staff organizations. Before retirement, Dr. Felt served as the Director of Space Architecture and Integration at the Office of the Assistant Secretary of the Air Force for Space Acquisition and Integration. And prior to that, Colonel Felt was commander of the Phillips Research Site and director of the Air Force Research Lab's Space Vehicles Directorate. Dr. Felt has a bachelor's in electrical engineering from Duke University, a PhD in electrical engineering and computer science from UC Berkeley, and an incredible track record of visionary leadership in the aerospace defense sector. So, Eric, welcome back. It is truly such an honor to have you with me today, sir.
Thank you, Tim, and thank you for the kind introduction, for the opportunity to be with you today and do my first interview since retirement. So appreciate the opportunity.
You know, it's wonderful. Let me thank you for your career of service. You have fostered so many technological achievements and helped keep our country safe. So thank you so much for that. And one of those achievements, actually, this is the reason that I had to talk to you today. I'm so excited about this. Last time we talked, though, you were still at AFRL. So if it's okay, let me start out by asking you to bring us up to speed on your current role and what you're doing right now that you're most excited about.
You bet. And again, appreciate the opportunity to be with you here today, Tim. And after AFRL, I took another assignment in the Space Force since I had moved over, and I wanted to be part of the ground floor of our new service. And that assignment was in the Office of the Assistant Secretary of the Air Force for Space Acquisition and Integration, Mr. Frank Calvelli there in the Pentagon. And I was the Director of System Engineering there, which included architecture and integration between the various programs that we were implementing, and with a big part on analysis of the whole portfolio and how all of these Space Force systems are going to work together. So we thoroughly enjoyed that work, and we're going through a period of great change and transformation within our DoD and our Space Force. So loved the work that I was doing there. Decided to retire here on June 1st, so just last month. And what I'm doing here in retirement is some consulting work especially with companies that are working on their go-to-market strategy with new technology and bringing that to the DoD, and others that want to assess the value of technology to potential commercial and DoD customers, such as private equity and things like that. So I kind of stumbled into this as clients started coming to me, but I've really been enjoying this next segment as well, and helping bring technology to the warfighter just from outside the service rather than inside the service like I was doing before.
Well, and that's absolutely wonderful. I have an enormous audience of professionals in the aerospace community, and so I will put some links down below where they can learn more. They can connect with you through LinkedIn. Hint, hint, they don't have to, but they could absolutely benefit from your experience. So I'll put that little plug in there. I want to get into AFRL Rocket Cargo. This is one of the boldest, most audacious projects the Air Force has undertaken, using reusable rockets to deliver a C-17's worth of cargo in an hour anywhere on Earth. This was one of your projects when you were at AFRL, right? What can you tell us about it?
The project wasn't directly under my part of the AFRL organization, but it was certainly one of the 4 Vanguard projects that we started while I was at AFRL, and was intimately involved with the project, and certainly very excited about the project. The most amazing thing to me is that it is not a new idea. When we went back and looked at history, they were in the 50s. They thought this would be great to deliver Marines by rocket. And then in the 60s, they tried it again. Even when I was at DARPA in 2007, as part of the Falcon project that we had at the time, we envisioned delivering Marines by rocket. And we even had some Marine volunteers that said they'd be happy to be the first Marine to go be delivered by rocket. So not a new idea. But what's different now is that the technology is finally mature enough that we can actually envision doing it, and we think it's going to work and actually be affordable for some of the missions that it's going to enable. So the technology is now ready for an old idea, but it's a very exciting idea and something that's going to provide a lot of potential military utility.
Well, let's put a pin in that. I want to come back to that because, yeah, like you just said, the technology, the idea has been around for a long time. The technology and the cost is catching up with that, right? And so it's one of those things where when people look at that, I know when I first looked at it, I was like, that's crazy talk. Using a rocket to move things point to point on Earth? How can anyone afford that? But then when you get into the cost structure, it's actually feasible. And that's the part for me that's mind blowing. Um, so, what I wanted to touch on though was what the Air Force is currently doing with it. And I know that you've just retired, but the Air Force, again, started studying delivering cargo via rockets back in 2018 for this program. And just this February, the Air Force filed a notice of intent for a test location at the Johnston Atoll, which would involve up to 10 reentry vehicle landings annually over 4 years. So my takeaway from that was rocket cargo is still a go. This is something that is still being pursued, right?
Definitely something that the Space Force is still interested, a capability in which the Space Force is still interested, because again, it would provide some great capability to the DoD. And now the important thing to remember here is that we're not paying for the development of the rocket cargo capability itself. That's something that SpaceX and other companies are working towards as their own development initiatives for commercial customers. And then what the Space Force's emphasis has been is how can we, if this capability and when it is proven and viable, how can we use it for military applications? And when we do, we may need locations from which to launch it and or to land it. And so that's what part of the Johnson Atoll idea was all about. My understanding, and I wasn't part of the recent discussions to suspend or withdraw that application for now, but the fact remains we will eventually need some locations to land this capability when it's proven.
Yeah, yeah. Well, so back in 2020, NASA reported that using SpaceX for ISS payloads had reduced costs by 75%, and that number continues to drop in terms of cost. That was also the year that the U.S. Transportation Command consulted with SpaceX on the delivery of 100 tons of cargo, again via rocket, anywhere in the world in under 1 hour using Starship. So one of the things that I was wondering was how much SpaceX specifically influenced this idea of AFRL Rocket Cargo, especially with the self-landing rockets as well as these cost reductions that we're seeing.
Well, it was a huge influence because they're obviously a leader in this in the launch area, and really, by our calculations, the SpaceX has lowered the cost of launch on a per kilogram basis by 90% already. Over say 20 years ago when we had government only capabilities, and they're looking with Starship to have another whole perhaps factor of 10 lowering of that. So that enables all kinds of new missions, all of these proliferated LEO missions that we're able to have now as part of the architecture. And rocket cargo is one of those that might have been cost prohibitive before or technology prohibitive before, but may not be now that it's that the technology has been is more mature. If you think about it, we basically tried to build these space planes for decades, in several attempts at that. And the vision was, okay, planes work great in the air. Why don't we use them in space as well? And they can help us with the portion of getting to orbit that's where you can have aerodynamic effects. What turns out that the wings and the structure weigh so much, and that just the environment is so harsh that complete reusability of the space planes was elusive and never met the cost goals that were envisioned for it over the decades with the shuttle or the X-37 or any of the follow-on programs that have happened. And so what SpaceX decided, using engineering, was that you don't need wings. We can come back and we can launch just with reverse rocket thrust, and that turned out to be a key breakthrough technology that they were able to perfect amazingly after many failures. And if you haven't seen the video of all the attempts to land the rocket and all the failures and learning that occurred in order to get to where they are, I thought that was a very impressive video. But the result is we have the right way to have a reusable rocket now that is able to do that in a cost-effective way. And so that technology breakthrough, the idea of don't use wings, use reverse thruster that SpaceX had, has really enabled this program and enabled it to be cost effective. Now, SpaceX, again, not the only player here, but they're certainly the leader in this area, and they're likely to offer the first capability. But that tech breakthrough and then the lowering of the costs of launch in general were the key things that are the reason we're here talking about it today.
Oh, absolutely. Well, and again, the Air Force has been looking at this for a number of years. And as you mentioned earlier, this idea goes back decades. But what is interesting is SpaceX announced this month that it's beginning a program called Starship Earth-to-Earth that promises most international long-distance trips will be completed in 30 minutes or less. So I did a little research on their website, and in terms of time savings, a commercial flight from Los Angeles to New York typically takes about 5.5 hours. From Los Angeles to London, typically 10.5 hours. Now, if a person uses Starship instead of a commercial airline, those flight times are 25 and 32 minutes respectively. So there are a lot of big ideas associated with this, but one of my takeaways was it sounds like SpaceX is moving forward independently with what sounds almost like a civilian version of Rocket Cargo, right?
That was always the vision, is that they are going to develop this as a commercial capability. The Space Force's role was to figure out how we were going to be able to use and leverage this commercial capability as it matures. But I was very excited to see that that next step when they released their website there, and excited to see that they may be able to offer this as a commercial service for passenger transport. The key thing, if you think about it from just a expenditure of energy perspective, if they can make Starship completely reusable, which is certainly their vision, then it gets down to, well, what's the cost of fuel to deliver something via rocket versus via airplane? And you can imagine it's not going to be it could be quite a affordable option eventually. There's a lot of tech work and maturation that needs to happen, but I'm just excited by the vision.
Yeah, no, the vision is amazing. So let me get into kind of the cost savings, because for me, this was the part that was mind blowing. And I approached this just as kind of Joe Average on the street, where I was always like, okay, it costs millions of dollars per pound that you put into orbit, right? So rockets, moving cargo is just, cost prohibitive. But then I saw an article by Next Big Future, and they reported that Elon Musk hopes Starship can bring the cost of rocket cargo down to $10 per kilogram, compared to $3 to $7 per kilo for air cargo. Brian Wang, writing for Next Big Future, estimated that SpaceX could achieve this if each rocket is reused 100 times at full capacity. So in the civilian world, this might position SpaceX almost as a premium cargo delivery service, much like FedEx is in the commercial package space, right?
I think that's exactly right. And again, if you can get to complete reusability or reuse it 100 times, it really does become a viable concept and quite affordable. Because again, think about the energy that's required. If you're going to need a certain amount of energy to get up into to launch it, but that you can quantify the amount of fuel that's required to do that, and $10 a kilogram seems to be the bare minimum cost of fuel to do that. But if that's the only energy that you need, and once you're up there, you can go all the way around the world, and there's no friction, no resistance, no air resistance or anything, and then coming back in is not going to use very much fuel except for the landing part. So you can imagine that if you can get to this vision of reusability, that it could be even less expensive than air travel, because an airplane has to fight. Now they're pretty high, so there's not a ton of air resistance, but you can imagine the analysis that would lead you to conclude this is not a crazy idea.
Well, the air travel actually was the next cost breakdown that I looked at, because the passenger service aspects of this are intriguing, right? I think this is the part that's probably going to really grab people, riding on a rocket right on the very edge of the atmosphere, being able to go around the entire planet in half an hour, right? I mean, it's an inspiring vision. So in terms of international airline tickets, they typically average $1,200 for economy and up to $7,000 per ticket for business class flights. Now, for the typical American adult, I looked that up, they're 170 to 180 pounds. That's around $685 to $40 per kilogram, depending on what kind of ticket you buy. So based on that cost structure, I mean, you have this massive variance in terms of cost, right? But SpaceX may be able to directly compete against airlines for passenger service. They may be able to undercut airlines for first class service.
I think the economics supports everything that you just said, and that's why it's so potentially exciting. Heck, sign me up. I would love to be transported by rocket cargo as that becomes a safe and viable way to travel around the world. Now, before we get, so I'm super excited about the vision. There are a ton of technical challenges that need to be solved. And that was the vision, by the way, of the space shuttle too at the time, was it was going to be fully reusable and super low cost. And it turned out that the maintenance and the operations costs of it were much, much, much higher than originally envisioned. And so that's a risk to fully realizing this vision. But those are all things that can be worked on and refined over time. So I think your analysis is spot on. It could potentially get to a very cost competitive means of transport. And of course, delivering, people will pay a premium for the speed of getting there faster. And that's, of course, why it's particularly of interest to the DoD, because there are some missions that it would enable us to do, such as military resupply, that if you can get those supplies there in 30 minutes, it's the difference between victory and defeat in a military conflict, or deterring a conflict from starting in the first place. So the military utility of rocket cargo is potentially very high for some applications, because there's no other way to get those missions done. And so in that case, we almost don't care how much it costs within the realm of affordability if it enables some new missions. And so I think the hope is that in the early stages, if we can start using it for some of these military missions that are particularly no other way to get the mission done, then that will continue to mature the technology, and then we eventually end up with super affordable civilian transport and civilian cargo delivery as well. So that the vision is that over time we will evolve towards that.
Well, and that lets you work the bugs out of it too, right? And that was, like you'd mentioned earlier, all the failed landing attempts. I think we've all seen dozens and dozens of videos of Starship blowing up either on the pad or just above it, right? I mentioned this idea to a friend, and I said the other day, when I was working on the research for this, I said, you could get from LA to New York in half an hour. And he said, I don't know, it's kind of dangerous. You first. So, there are things that have to be worked out. But if you look at how the safety has progressed over time, just with traditional SpaceX launches, right, it just gets better and better and better.
Well, we're not going to be transporting passengers until it's proven safe. There's no doubt about that. I don't think anybody needs to be worried about that. But there will be a long journey to get to that. But there is no reason to think we can't eventually get there. And in the meantime, there's the transporting of cargo is very viable and doesn't require such a high standard of safety. It's just like resupplying the ISS. I mean, the standard for taking cargo up there, the safety standard for taking cargo up to the ISS is of course much lower than the standard for taking humans up there, as it should be. And so we've got all kinds of processes in the government, and every government in the world has those for reviewing those safety things appropriate to the mission that's being done. So long ways from passenger transport, but by the time we get there, it'll be safe. And again, sign me up. I would do it.
Well, if it's okay, let me ask about the environmental impact, because one of the things I was trying to look at are what are some of the stumbling blocks for this. Now, a typical long-haul plane flight creates 1 to 3 tons of CO2 per passenger, whereas rocket launches generate 50 to 75 tons of CO2 per passenger. So they're just a lot dirtier in terms of their environmental impact. Right now, that's not an issue because there are so many more commercial airlines than there are rocket launches that it's just, they outweigh them, right? But In terms of rocket cargo and potentially passenger service, if this becomes something that is more frequent, that's something we'll have to deal with. Do you see a way to keep the environmental impact down with like green fuels or anything along those lines?
Yes, I mean it goes right back to the cost. Again, if you assume that the cost is going to be competitive with air travel, then you can get to a point where the environmental impact or the carbon impact is equivalent too, because it's going to take a certain amount of energy to accomplish the mission, and the energy is going to be highly correlated to the cost, and it's also going to be if you optimize the fuels, highly correlated to the carbon impact.
Hmm.
So over time, there's no reason, and there's lots of research going on green rocket fuels. It hasn't actually gotten as much traction as you might, as it will eventually, because the quantities are so low. It's not really, high return on investment to go after that right now. But if you had a lot of this rocket cargo activity happening, then of course you would do all the fuels research to figure out how to, be more and have better environmental fuels and higher performing fuels. But it all comes down to what is the basic amount of energy that's needed. And yes, for the foreseeable future, you have to use carbon-based fuel to fuel rockets because the margins are very low. But that's okay. I think it'll be on the order of the same as air cargo eventually.
Yeah, well, and that's the natural evolution of what we've seen with automobiles and aircraft and every new technology, right? It doesn't start out perfect, it gets refined over time into something that just becomes better and better and better. So, this idea, I did, again, a little bit of research on this. I believe it goes back to Hermann Oberth, who was the famous German rocket engineer. He suggested using rockets for mail in a 1927 letter, if I remember correctly. And a number of rocketry pioneers have actually tried that over the years, from the 30s through the 60s. There were a bunch of these little point-to-point launches, from one town to the next. Some really interesting history there. And as you mentioned earlier, in 1963, General Wallace Greene proposed Project Ithacus, where a battalion of 1,200 rocket commandos will be deployed anywhere in the world, about half an hour, to reduce the need for overseas U.S. Army bases. And I thought that was really intriguing, right? So he was thinking about the cost savings even back then, because again, these are very expensive flights, but when you look at the cost of an entire base, then you can offset that, right? So, I mean, the idea isn't new, it's enabled by lower costs and higher tech today.
That's exactly right. I actually didn't know that the idea went back to 1927 of mail delivery. I love that because, of course, mail delivery is what enabled commercial airline flights to proliferate around the world so effectively. And it was not more cost effective when they started that than sea and terrestrial delivery mechanisms. But they used it as a way to kickstart the commercial airline business, and they used it very effectively. And so that's a good model that might apply to this as well as we move forward. No reason to think that that's not possible. I don't know if delivering mail is needed at those speeds, but anything that needs to be delivered that quickly and can pay a premium for being delivered that quickly would be a viable cargo to be transported.
Yeah, the paradigm starts to shift the more you dig into this. I found myself thinking about it in a much more broad perspective as I was working through all the documents and historical data. And like again, rocket cargo is a bold, audacious project, right? I mean, this is a big vision, and lower costs and better tech are driving it forward. I'm wondering if we could see rocket cargo and SpaceX Earth to Earth bring rockets into our daily lives over the next few decades as a new part of today's airline industry. I'm not even using the right word there. It would no longer be the airline industry. It would just be the air travel industry or something along those lines.
Yeah, well, if you think about the infrastructure required to support proliferated rocket cargo system, it's less than the airports that we have now to support the air travel industry. So it's completely viable as the safety's matured, the technology is matured, and I think it's kind of exciting. It's like the Jetsons. Maybe we're finally getting there.
Wonderful. Eric, let me thank you so much for your time today. Again, it has been a true pleasure, an absolute honor having you with me. Let me thank you one more time for your career of service. And I know that you were doing wonderful things in your retirement as well. So this was just one part of the journey, and you were going on to some really exciting future projects. Let me close by asking what some of those are for you in the next few months.
Uh, some of the future projects, I mean, I envision myself doing the continuing to bring technology to the DoD, just like I was doing in government service. I think we have a pretty good understanding from the analysis that we did while in the Pentagon of, what are the gaps and what are the highest return on investment opportunities. And what I see in the new budgets that are coming out, and in the money that's being applied to Golden Dome and the other projects, is that our government is funding some of those most important capabilities. And so we're headed into a very exciting time for our Space Force and for space innovation and activity in general, and really look forward to being a part of it with you. So appreciate your time today to talk about rocket cargo, one of my most exciting things to talk about, and obviously yours too. So I'm glad we share that passion.
Absolutely. Thank you again so much for your time today, sir.
Thank you.